predicate, individual constant, argument. I'm putting an asterisk by the word argument because there is a specialized sense of the word in connection with talking about sentences, and then there's the more common sense of the word. We've already talked about it and we'll continue to talk about it. Then we want to also mention, Arity. And I'm going to, I should also mention that in terms of let me say two things. One is in terms of the commonly used language in the course, I have a tendency not to use the specialized sense of argument and to rarely use arity, but because it is this is language that does come up in the text, it's good to kind of have it in our pocket. Speaking of specialized language or technical terminology, the glossary, which begins on page 579, I think. Obviously, the pagination, remember, for the paper book as well as the ebook is the same, so 579, 580 is the glossary. Some of you are going to say, I don't like learning by kind of being told a bunch of technical terminology and their definitions. You know, I learn by doing. Don't worry, that's what we will do. I just want to make sure that we go through items that are going to be that we are going to enlist, you know, for the whole semester, so that we get ourselves off using the language, looking at the language that we're going to be using. And then in chapter 2, we've got, I've got one more item here, truth value. And then in chapter 2, we'll have the more common sense of the term argument. We'll talk about sentence or statement, and premise, conclusion. We'll talk about inference, implication. And then Thursday, we'll get into it a little bit today, but on Thursday we'll talk about the concept of valid, or the concept of validity, and logical consequence. We'll talk about analytical consequence, and we will talk about concept of soundness. So the idea is going to be that when we walk out of here today, you'll say, yes, I know how to generate an atomic sentence in the language of first order logic, that is, in the language that we're learning. I know how to generate that sentence not only by, handwriting it, but I can also use Tarski's world, and you'll be delighted to know that I did bring my, hold on, I gotta find it. I did bring the thumb drive on which I have all the programs. So in connection with this, we'll talk more about not just what programs we're going to use, but also how we want to get started on them. We'll take a look at our schedule so we can see where we're going next week. Just as a quick FYI, we do hit the ground running insofar as by the end of next week, if I'm not mistaken, we'll double check the schedule, we're going to write an exam on chapters 1 and 2. There's already practice exam posted, and so we'll go over all those details. Don't stress over all that stuff now. Sophia, what are you thinking?
Is this class, would you like go over how to sign into the like homework and textbook of this class?
Not in the class. We will do that. If not today, definitely on Thursday. If you can't wait, there are some how-tos, some tutorials on each of the programs for our purposes. That is, for the purposes of homework, it will be the Tarski's World and Fitch programs to do homework, and then the Submit program to send your homework to the grade grinder. Anything else, Connor? What are you thinking?
Wait, so when it says like 1.1, 1 point whatever on the list
Yeah.
of assignments, that's do we find those in the programs?
Right, right.
Okay.
And we're going to start working on that ideally today.
Okay.
So as an example, let me just grab, okay, so all the way in chapter 9, right, on page, I don't know what it is, but there's 9 point, I think that's 1.8, right? So exercise 9.18 is associated with a specific pre-existing file. I think in this case it should be Tarski's World. So what you do is you open up Tarski's World, which we're going to do today. You would then open up that pre-given file, and then you follow the instructions in the textbook for how to do the exercise. So the vast majority of exercises involve you sort of toggling between the book and the actual exercise on the program. Okay? And we're gonna work on that today. We're gonna work on the first of our programs today, and then as Sophia's pointed out, we'll definitely look at how you save your homework, and then how you send it in for the grade grinder to look at. But first, I hope it's the case that some of this language looks familiar. It's language that some of which we would have had on the board last week. We would have talked a bit about it. If you say, "Not me, I don't remember a thing," that's okay. I'll not guarantee you, but I'll bet that as we go forward, you'll say, "Oh yeah, kind of, I do remember that." All right, so let's start with what's known as an atomic or simple sentence. Now, here's the fancy pants, really mouthy definition of an atomic sentence. An atomic sentence is the smallest linguistic entity that has a truth value. Is that perfectly clear? Of course it's perfectly clear. The smallest linguistic entity that has a truth value. Let's do something simpler. But it's not super much helpful. So it's not super much more. It's not more helpful, insofar as it's going to involve language that we haven't learned yet. An atomic sentence is a sentence that doesn't involve a connective. That's an awesome definition, but again, not super helpful because you're saying, yeah, but Mia, what's a connective? So let's start with this instead. An atomic sentence is the most fundamental or basic linguistic unit or basic sentence. Okay, so let's think about it in two ways, each of which, if I'm not mistaken, we looked at last week. An atomic sentence was, or an example of an atomic sentence was, Joe sits. Does that ring? Yeah, did we do that one? Now, when I say it's the smallest linguistic entity or the smallest linguistic unit, blah, 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 it doesn't have to be number of words. I mean, the sentence Joe sits is really short, 2 words, right? Subject, verb, right? Or if we want to say subject, predicate. But remember also the sentence, Barack Obama was the 44th president of the United States. That's also a simple or atomic sentence. It's got a lot of words. It's got a dependent clause, right? But insofar as an atomic sentence is atomic, what we mean by that goes all the way back to the days when we thought that an atom was what? The smallest unit? Yeah, the smallest possible material particle. Like, you couldn't break up an atom any further. We've since learned that's not the case, right? But now let's think about an atomic or simple sentence in this way. You can't break down an atomic or simple sentence, can't break it up, without, in so doing, losing that sentence's truth or falsity. Okay, so if I just say, Joe, you're going to say, great, Mia, that's a name. But Joe sits is true or false, right? Barack Obama, that's a name. Barack Obama was the 44th president of the United States. That's an atomic sentence. Okay. So now we want to take a look at what the constituents of an atomic sentence are, and you couldn't have one constituent of an atomic sentence without the other, and still have a sentence that is true or false. Cody, what are you thinking?
Is atomic sentence simply restricted to like name, like let's say if you were to take it apart, just a name? Can it also be like, for instance, like if you were to take apart, let's say Joe sits, and it's just sits?
Yeah.
Is this the same thing like the other way?
Yeah, so in order to have an atomic sentence, you need a predicate and a constant. And you said name, and you're exactly right. Does that make sense?
Yes.
So when you have a predicate and an individual constant, you're talking about, remember we said this earlier, these are the constituents of an atomic sentence that is of the singular variety. Don't worry about that language now. Remember, if you want, go back to last Thursday, and we talked about two sentence types, right? We talked about singular sentences, and we talked about quantified sentences. We won't get to quantified sentences until later. We're talking about, right now, singular sentences, and then in chapters 3 and following, we'll get into, sorry, I said singular, I meant to say simple sentences, atomic sentences. So chapter 1 and 2, atomic sentences. Chapter 3, we get atomic sentences, and then we compound them. So that's where we're headed. Okay. So we've got a predicate and an individual constant. So remember, we've got, for example, Joe sits. And as Cody points out, if we dismantle that sentence, right, we're going to no longer have a sentence at all, right, let alone one that's either true or false. So as a reminder, when we're dealing with logic, we're dealing with a certain sort of sentence that is typically called a statement or a proposition. For our purposes, we'll use statement and proposition and sentence interchangeably. And we'll say that a proposition, a statement is a sentence that is true or false. That is, a sentence that has a truth value. Okay. Now, when we're talking about the sentence Joe sits, Joe is the individual constant, the name, right? In this case, the grammatical subject. Sits is a verb, right? But it's predicated of Joe. So we'll say that a predicate is going to involve, sorry, let me back out of that. A predicate is what we say about an object, right, or a relation. Does that sound fair enough to say? And again, I hope that it's that when we're sort of moving back and forth between very technical and less technical language, one will help you make sense of the other. Right? So a predicate is some sort of property. sitting is the property that we're ascribing to Joe. Okay. Now, how are we going to notate this? What's the language that we're going to use? Well, we're going to have predicate first, and the first letter of the predicate is capitalized. And then in parentheses, we have the individual constant, as Cody says, the name. Okay? So in this case, we have sits, lowercase Joe in parentheses. So, obviously the notation that we're using right now consists of letters that we already grasp, either natively or in terms of a second or a third language, right? In other words, this isn't in Cyrillic, right? It's not Chinese characters. These are English, well, for our purposes, English language letters. And then we know what the parenthesis or parentheses symbol or symbols is or are. Okay. Now we're, as you already saw last week, we're going to learn some other notation that's not specific to the English language, right? But in all these cases, whether we're talking about writing it out in English, it still is the notation of the language of first order logic. Right, so we've got a predicate and an individual constant or a name. Now, just to finish up here, argument is in one sense, is what we say or what we call what goes in the parentheses. Okay. So we say that a predicate takes an argument, and the argument has a number, the number of arguments is its arity. Again, I don't stress over that, and sorry, hold on just a second, of course, sorry about the dinging. Today I got a Wi-Fi connection. Remember we were trying to get it the other day and it wasn't working, so my computer's blowing up. Anyway, sorry, so to reiterate, one sense of the word argument is the name or the term. We'll see as we go into quantifier logic, and instead of names we have variables, x, y, z, right? But in parentheses we've got the argument or the term, and then the number of arguments is the arity. Well, you might say, what do you mean number of arguments? We've just got one name. Well, as we'll see in just a moment, we'll jump on into Tarski's world, right? There are what are called relational predicates, right? So remember we said earlier that a predicate is that property of objects or relations. So we can talk, for example, about being in front of or back of, left of or right of. We'll see that the total number of arity that we'll ever deal with is 3. Right? So in Tarski's world, there's one predicate that takes 3 arguments. So you might be saying at this point, oh, this is very abstract. No, I'm not comfortable with this. Don't worry about it. It's about to get comfortable because we're about to go into Tarski's world. Right? How are we doing so far? So good. Okay. Hold on just one second. Right? Don't wait. Okay. So I think I mentioned to you. So what I'd like to do is sort of is toggle back and forth between talking about the logistics of our programs and using those programs so that we can learn logic. You'll see this is a bunch of junk that I have on this thumb drive for the purpose of making sense of the submit program that we'll use. I've pulled aside some exercises, right? So this is a proof file. This is a sentence file. I don't know that I have a world file in here. But at the top is what we really want to look at. This is the LPL software. Now, if you either do not have access to, you don't have your own laptop or tower, so let's say you use the library's computers, or you use something at work, right? I recommend that you save the programs and the e-text and your homework on at least one thumb drive, a flash drive, right? Like I put into this machine. And you can carry it around with you. It's really easy. Also, as with all of your work, I strongly recommend that you always save a backup, right? So that if something, something explodes, you're not without all the fruits of your hard work. Okay, so remember that we've got the Tarski's World program. This is just a repetition. I'm not quite sure why I have that. Doesn't really matter. This is the installer file, or installer program. So we have Tarski's World, Fitch, Boole. Those are the three programs we're going to use to learn logic, to complete homework that we then send by way of the submit program. Okay, so that's where we're headed. For right now, though, in keeping with our discussion from the board, I'm going to open up Tarski's World. I don't recall, I confess, whether or not what you get is Tarski's World 5 and 6 or just 6, but I think it's version 6 that you want to work in. Took forever to open. This window, don't worry about. That's pure text security. You won't see that. Instead, ta-da, you'll see a world. Now, if memory serves, we did open this sometime last week, right? I hope that it's not unfamiliar. Again, don't forget, there's going to be stuff that we do repeatedly. After a while, those repetitions will fall away. But for right now, I'd rather repeat and have you be bored than have you not know what's going on. Okay, so let's do two things at once. Let's use our newfound language to say something about worlds that we'll build. Now, I don't know about you, but when I think of language, I'm oftentimes overwhelmed by the number and types of sentences that can be constructed. And it's like, how am I supposed to learn this new language? There's so many rules of grammar, it just, I feel lost. One of the great things about Tarski's World is it presents you with a very small world. First, the world is a checkerboard or chessboard, if you will. So Tarski's World is, if you will, a sort of a flat plane on which objects appear. How many types of object? 3. In how many ways in terms of shape? 3. Yep. And then there are some other things that we can do with these objects. The default is always going to be a cube that is small, or a small cube. Okay? So when you hit new, doesn't matter how many times you hit new, the small cube will keep populating row by row by row. Okay? So this is a cube. We can make it medium. We can make it large, right? But that's it. And if we want, we can change the shape. But we can't make, anything else. For example, you and I in the sentence pane can type the sentence Joe sits, but there's no world that we could make. Okay? So one of the nice things, fingers crossed, about Tarski's world is, as you're doing logic, as you're learning logic, you're going to not feel overwhelmed by, if you will, rules, because there's a limited number of objects and things that you can do with them. I hope this will make more sense as we go forward. All right, so does everybody see we've got on the far left of the types of object, we've got what are called tets. Then the middle type of object is called a cube, and then the far right object is called a dodeck. And there are three possible sizes, small, medium, and large. Now, notice that you can name an object one or more of 6 possible names. So there is no more than 6 possible names. And here's something interesting for us to think about when we learn that once you've given an object a name, the name is taken. Notice when I click on the dodeck to highlight it, the letter A, the name A, the individual constant A, the letter D, the name D, the individual constant D is shaded out. Can't use it. Right? Why should this be the case? Let's think about this a little bit. Why do you suppose Tarski's world was written in such a way that precludes, that is, prevents 2 objects from sharing the same name? What do you think, Adi? Yeah, you know which one you're talking about. Example. I don't know anybody else named Adi. Does that mean that there is no one else in the universe named Adi? No, it doesn't. But, I'm not worried about confusing you with someone else, namely because you're the first Adi I've met. On the other hand, you probably know more than one Mia, or know of more than one Mia. Or I'll pick on Sophia. I know of more than one Sophia. So how do I know which Sophia I'm talking about if I know multiple Sophias? Well, I might do something like, well, it's Sophia, and then I give the last initial. Or it's Sophia from blah, 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 right? Or how do I know that this is Jennifer Lopez and not some other Jennifer Lopez? Well, that's because that's Jenny from the block. Some of you are like, I wasn't born then. Right, so we need to find ways to distinguish, right, an entity as being this and only this entity. And this will actually become a really important point about an assumption we make about reality, about the way things are. Okay, so an object may have multiple names, but no 2 objects can share a name. Okay, so a thing is what it is and is not something else. A thing is identical with itself. Okay. All right. How about this? I've clicked now on the sentence pane, and P.S. as a reminder, or this may be brand new, even though when we open up the Tarski's World program, we are presented with an untitled world, look at the upper left corner, and an untitled sentence, lower left corner, these 2 panes appear together and they're part of the same program, but they are two different file types. It's like saying Microsoft Word .doc versus Excel.xl web, right? Does that make some sense? Why do I say this? Well, because when you're either opening a pre-given file or you're saving a file as, you have two different extensions. We'll talk more about that. All right, so let's use our newfound language. We've made a world. We're pretty creative, right? We've made a world. Using these buttons, right? Can everybody see these buttons? Tet, cube, dodec. Can you tell me a sentence that you take to be true? Given the world and given those three buttons. What do you think?
That specific world?
Mm-hmm.
So is it like 3 different clauses?
No. So I apologize. Let me be more precise. Give me an atomic sentence that you take to be true using one of those 3 buttons. Just utter the sentence. Pardon? Okay. We've got cube, right? Does the cube have a name? Okay, should we notice, let me make the sentence text size bigger. Notice when you use the button, you can type it, the sentence and elements in manually, but when you use the button, you've got pre-given items, which is really helpful. So notice that the highlight within the parentheses is basically saying, hey, you haven't given this thing a name. Okay, so in order for us to construct a logically grammatical sentence, we're going to need an individual constant. So I want to say, not Michelle. Janet, I was close, right? Janet's going with Q, Natalia. Do we want to say, well, right now we only have 2 names. And, well, heck, don't worry about the sentence being true. Let's say that A is a Q. Okay? Now I'm going to come over here to the verify button. And when I hit verify, I get an F. Okay, so let's pull together a couple of items we've already discussed. First, we have an atomic sentence. We have a predicate and an individual constant. Right? So we've got, if you will, the smallest linguistic entity that has a truth value. What is the truth value of this sentence? It's false, right? So notice also, we mentioned this last week, the way that we understand truth and falsity is as a property of sentences, in this case, whether or not the sentence corresponds to the world. Does that make sense to say? So here's a way that we can think about truth. In Tarski's world, when we're dealing certainly with atomic sentences, truth is a matter of sentence corresponding or not corresponding to a world. You might say, duh, Mia, but things will get more complicated. So just let's hold on to this as something that I hope makes sense. Okay, so it's false that A is a cube. What if I say, I'm going to go ahead and delete A. What if I go ahead and type F? And I hit verify. Notice I get a little plus sign. When a sentence is true, Kyle, right? Yeah. When a sentence is true, you'll get a capital T, and it'll be in green. It's like, yay, green for go. And then when a sentence is false, you'll get a red for stop. I don't know. I'm guessing. All right, so the plus sign tells us that there's something hinky going on. Question for you. Does F appear anywhere? Okay, so since there is no world that obtains with F, we can't evaluate the sentence as true or false. Now let me throw out I'm going to fudge a little bit here, but this might help you make sense of it. Atomic sentence, God exists. You can't evaluate the sentence God exists according to the correspondence theory insofar as you can't poke a stick at God, right? The sentence that F is a cube is true or false as long as F obtains, F appears somewhere, right? So the sentence God exists isn't evaluatable in terms of truth and falsity if we're looking at this conception of truth. Okay? So what if we click on the cube and we name it F, come back, verify, now we get our green T. Okay, so one of the things that Tarski's world is going to do for us is provide us with a very intuitive or comfortable way, familiar way, right? A familiar way of thinking about truth and falsity. Okay, we'll think of truth and falsity in additional ways. This is a nice way to start. All right, so some features of Tarski's world that we should consider. When you read your book, when you look at the user's manual for the software suite, that also comes with the book, both the hard copy and the e-version. Let me show you really quick if you don't believe me. I'm going back onto my thumb drive here. If I back out and I click on LPL Extras, there's the textbook and the software manual, right? Anyway, you'll learn some things. For example, let's go ahead. So for example, and hold on just a sec, let's go ahead and name the DODEC. What name do you want to give the DODEC?
CB.
Okay, so Connor says the DODEC has two names, C, B. We'll talk about multiple names in just a moment. Let me flip the view here. You've got a bird's eye view, and then you've got the straight on view. You can flip this thing. You can rotate it, right? I don't do that because I get dizzy. By the way, the view is kind of standard. You're facing the board, left, right, front, back. Okay? All right, so with that in mind, a couple interesting features about Tarski's world. Does everybody see the button for between? Okay, so I'm going to I'm on a Windows-based machine, so I'm going to click or tap or type Control A, and I get a sentence after. If you're using an Apple machine, it would be Command A, or you can go up to this sentence drop-down. You can add a sentence before, a sentence after. I'm going to click the button between, and I want to ask you a question first. What is the arity of the predicate between? It is D says, it's a three-place predicate. Makes sense. How do we read these sentences? Well, you probably have some idea. This sentence says F is a cube, or cube F, but F is a cube. X is between Y and Z. You okay with that reading? What do you think is a true sentence using the between predicate? It's a relational predicate, right? Okay, so Natalia says CB is between F and AD. Now, can we use both CB together? So Natalia's thinking yes, Adi is thinking not sure. To Adi's right, yeah, I'm sorry, you are? Miguel, you say no. Talk to us about this. You're correct. Why are you correct?
I just want to say no because like I have some experience like learning to program and like when you write stuff like that, you only use one word. I use names.
Yes, so you have one name per space. And what do I mean by per space? Either one name in front of each comma, right? Or adjacent to each comma, or if you have just a single place predicate, it's one name within the parentheses. Now, if you're not sure, so Natalia, it's great that you mentioned this. If you're not sure, because using the buttons pre-populates fields for you, at least in some, provides you a portion of pre-population. Let's go ahead and click C, and notice you're moved right to the next individual constant. So we'll just pick C. And then Natalia says C is between F and I'll just grab A. Doesn't really matter, it's arbitrary. Okay, is everybody all right with that? Now, between has a restricted use in Tarski's world. So if you find yourself doing something like the following and saying, yeah, it's the case that C is between F and A, just like I might say that you are Andrew is between Kevin and Jason. So I would say Andrew is between Kevin and Jason. I think most of you would agree. But Tarski's world is going to say no. Okay, so there's a restriction here. So if you were to hit verify and you get an F, you'd say, what? The relational predicate between requires that your items be on the same row, in the same column, or on the same diagonal, okay? You'll learn this as you go forward. To the best of my knowledge, there's nothing logically significant about this. It's a restriction that allows the program to be streamlined in some important ways. Okay, so far so good. And here's something else, and let me use the bird's eye view again. If we've said that, or we've made the dodec CB large, correct? Can you see that the largeness of this object precludes, that is, prevents another object from adjoining it, right? So, if you're trying to do that, you're not gonna be able to do that. Okay. So, as you're starting to learn, work with the program, just mess around. It's not gonna hurt you. Okay. Before we move on, we can hit verify all, right? So if you have multiple sentences that you want to check, you can hit verify all. Now that we know something about the between relation, what can we do to make this sentence true? What do you want me to do? There are a number of ways you can make the sentence true. What's one of them?
C down.
Okay, so Adi says, let's move C down so it's on the same row. Yep, we can do that. Oops, sorry, I didn't do it. Okay, so it's on the same row. We can put them on the same diagonal, right? So either gray or black. So it's got to, the objects have to all be on the same color on the diagonal. So you can have that same diagonal. You can also have them in the same column. Okay, so far so good? Okay, what do you think, Natalia?
You're not able to separate them, correct? As when they were side by side, that B is always part of the C? It wouldn't.
Yeah, so here's how we're going to articulate the names. So this, I'm so glad you asked that question because it allows us to segue to another important concept. Is it fair to say that A and D name the same object? Okay. Would you say that A and D are one and the same? Okay. Question for you. Is 50 Cent identical with Curtis? What's 50 Cent's name? What? And you are? Oh, Rampton. Okay, good. So, yes, so Rampton says 50 Cent is identical with Curtis Jackson, right? Lady Gaga is identical with, I don't know what you kids listen to. We don't know, yeah, so we'll make something up. Lady Gaga is identical with Jane Doe Italian, Italian ending name. Can't even make a complete sentence, right? Samuel Clemens is Mark Twain, is identical to. So when we've got two or more names and we want to articulate that these names belong to the same object, we'll say, in this case, for example, or one of these cases, we'll say A is identical to D. Okay, does that make some sense? So we're making identity claims with these names, and now we can circle back to the point that was made earlier about two or more objects not being allowed to share the same name. That's because an object is identical only with itself, and the object's the subject, if you will, is this name, whatever it is, A, B, C, D. Okay? So, here's a question for you. I'm going to go ahead and I'm going to delete all of these for the moment. Let me put the A is identical to D back. Tell me something about A. Now, earlier, Janet was talking about the cube, and you actually asserted a compound sentence. And by compound, I mean a non-atomic. By compound, I mean you took two atomic sentences, cube, and well, let's say F is a cube, and F is small, so you compound it. Let's keep the sentence simple because we haven't yet learned how to notate the compound sentence. What can you say about A? Tell me something about A. Okay, so Rumton says A is a tetrahedron. So we click tet, we click the tet button, click the A button, we'll verify it. Rumton's right? Sentence 1 and sentence 2 are true. Question for you, if A is identical to D and A is a tet, what follows from that? D is a tet. You might say, dummy, I see it, it's right there. It's obvious, or I don't even have to think about it. Well, but you actually do, you're just thinking so fast, you're not aware of it. The inference that you just made is in terms of type, like the happy cows, right? Remember, gray cheese comes from happy cows. Happy cows come from California, so gray cheese comes from California. It seems so obvious you don't have to think about it. It's a matter of the terms relating to each other. Okay, so you can add a line after, and you can say, therefore, D is a tet, and you can verify that it's true. Now, it's true, the third sentence is true based on what the world says, but the inference has nothing to do with the world. The inference has to do with what you've claimed about the relation between A and D. It's an identity relation, and the status of A as a tetrahedron. Okay? I want to push on this a little bit more so that by the time we get to a detailed discussion of validity or logical consequence and an analytical consequence, you'll say, oh yeah, this makes more sense. Some of us find the concept of validity to be really discombobulating. It's like playing mental twister. So don't stress if that's the case. All right, so what you've just done is you've drawn an inference, right? So sentence 1 and sentence 2 imply sentence 3, or sentence 3 is inferred from sentence 1 and 2. In other words, you've just asserted an argument, right? So an argument is a collection of sentences, one of which is supported by the other or others. The end point, the inference that you make, is the conclusion, and the supporting elements are called the premises. So in this case, sentences 1 and 2 are the premises. They imply, sentence 3, the conclusion, tet D, or D is a tet. Okay. So far, so good, I hope. Right. Now what I'd like you to do, given the world that we have, and let's see, I'll just go ahead and delete these. Given the world that we have, I would like you to tell me something about a couple of relations. So remember, this is a one arity or a single place predicate. So tet is a single place predicate, cube is a single place predicate, dodec is a single place predicate, small, medium, large, single place predicates. Same shape? One single place or multi-place? Yeah, multi-place. How many arity? How many? So it's at least 2, right? And then if you say, well, I'm really not sure, well, hey, let's go ahead and click. You're given a 2-place. Is it possible that you can have a 3-place same shape? Yes, but our button's going to restrict us. All right. Left of, right of, front of, back of. We said same size, I think, but if not, we just did. Same column, same row. Smaller, larger adjoins. Between is the one 3-place predicate, right? Okay. What I'd like you to do, given what you know about the current configuration of the world, please use smaller, larger to give me 2 sentences. Go. Tell me a sentence. Here's a cube. Here's a dodec. Here's a tet. Using these relational predicates, give me 1 atomic sentence. What do you think? Connor and Miguel. You'll give me 1, Connor. Miguel, you'll give me another, please.
Okay. Smaller, and then parentheses F, comma, C.
All right. Awesome. Miguel, give me another.
Bigger, C, comma, F.
Okay. By bigger, you mean use the buttons?
Larger.
Larger, yeah. So remember, our language is going to be restricted to what Tarski's world gives us. So you'll want to, if you bigger is perfectly fine. It's just that we won't have a way to notate that in the program. We can notate it on paper. Okay, so I'm sorry, larger what?
C, comma F.
All right, CF. Okay. So what do you think? If 1 is true, must 2 be true? If 2 is true, must 1 be true? So we've got a guaranteed inference. Why is that? What do you think? Does the question make sense? Adi, what are you thinking?
It's the Boolean opposite statement, so can I explain it?
Is it fair to say if we know the meaning, if we understand the concept, the relational predicate smaller or smaller than, and we also know or understand the relational predicate larger, all we have to do is analyze the meaning of the predicate and we get the equivalence. Yeah? Okay, good. Well, hold on to that because we'll come back to it. Miguel, what are you thinking?
Larger and smaller are the same concept, but they're inverses of each other.
Okay, wonderful. Very good. So we've got, if you will, a semantic equivalence. Does that make the meanings of the terms are equivalent? All right. Let's try another set. This time, if you would, please stick with just one. So give me 2 sentences, each of which uses either just smaller or just larger. So I want 2 sentences again, please. What do you think? Doesn't matter. You can use one of the same ones. What do you think, Sophia?
Could you repeat the
Give me 2 atomic sentences that you think will truly express the world, but only using one of the relational predicates. So either use smaller twice or larger twice. What do you think, Cody?
Let's see. I'm gonna go for larger.
Okay.
C is larger than F.
All right. Do you want to do are you on a roll? You want to do another one?
Yes.
Okay.
And larger.
Yep.
I think it's A. Right?
Oh yeah, I'm sorry. Here.
A is larger than F.
Okay. Now I think you're going somewhere with this. Where are you going with this? Or let me ask the question a different way. If 1 is true and 2 is true, is there a necessary inference for you to make? In other words, must there be a sentence that follows from that? Right? And you might do something like this. I mean, yes, I know we see Tarski's world, but you might say, oh, I'm going to draw this, right? Okay, so here is F, here is C, right? And then A could be this. A could be this. In other words, it's not clear, if we ignore Tarski's world, it's not clear just from the sentences, is it, what size A is. In other words, if we don't look at the world, we just think about the sentences. Does that make some sense? Okay. So, question for you. What do you want to say? What's the third sentence going to be, do you think?
A and C are the same size.
Same size, A, C. Was that Kevin? Or no, is it, oh, Adi, okay. So I'm gonna click verify all. Now, it is the case that each comes out true. But what I want to ask you is this. So sort of bracket number 3 for right now. Focus your attention on 1 and 2. In addition, I'm going to, I made the world disappear. I've gotten rid of the world. What I would like you to do is look at 1 and 2 alone and tell me if there is a sentence at number 3 that you could create that's related. Maybe there's a larger relation or like a same size relation, but that is not true.
What's that?
Can you, so here's what I'm asking. Can you maintain the truth of 1 and 2, but can you come up with a false number 3?
Yeah.
Okay, do it.
Can I just ask a question?
Of course.
So the only way we know number 3 is correct is if we got the size of that f, and that f was like the middle size or medium, because then we know there's only one size they both could be.
Good.
But since we don't know if it's small or medium, then A or C don't necessarily have to be the same.
Yes, right. So you can falsify so let me back out of that. We don't know whether or not A is larger or smaller or the same size as C, right? So part of what we're after here is this. We want to say, since F is being compared to 2 different other named items, that relation transfers. But in fact, as Adiz pointed out, it doesn't transfer. It could be the case that A and C are the same size. It could be the case that A is larger than C or A is smaller than C. We just don't know. So let's take the number 3 that's up here. Let's suppose that we make the first 2 sentences true. So it doesn't matter what I'm sorry, I'm in the wrong pane. It doesn't matter what type of object we have. It matters size, right? Because that's what the argument is about. So, C is larger than F. So here's C. Make it medium. Make a new object. It's small. We'll name it F. Okay. Whoops. Number 1 is true. So far, so good. A is larger than F. New object. Make it medium. Call it A. Oops. And now we have, I said oops because I hit verify all instead of just verify. Now, it is the case that A is the same size as C, correct? But that's because that's the way the world is. But we can change the world. Make A large. Now, 1 and 2 are still true, but 3 is false. Okay. Hold on. I'm going to make a new sentence file just because I want us to toggle. All right. I'm going to eliminate the world again. How about this? A is larger than B. B is larger than C. Do you think there's a sentence that must be true that follows from these 2? What is it? A is larger than B. B is larger than C. So A is larger than C. Okay. Here's the question. Is there a world we could build? Is there a possible world in which sentence 1 and 2 are true while 3 is false? Some of you are saying no, Some of you are like, Mia, what are you talking about? This is where we start to play a little bit of mental twister. So don't worry if you're feeling a little bit discombobulated. Let's go back to the first one. C is larger than F, A is larger than F, A is the same size as C. We built a world in which these two sentences are true, the first two are true, the third is false, correct? Can you do that for these three sentences? Can you build a world in which A is larger than B, B is larger than C, but A is not larger than C? Can't do it, right? Okay, so when your premises entail or guarantee an inference, when your premises entail another sentence, right? That means that sentence can't be falsified. If those premises are true, the sentence that follows must be true. So let's go ahead and build a world, right? So A, B, C. A is larger than B, so let's make A medium. B is larger than C. Let's make B large. Therefore, A is larger than C. Oh, what did I do wrong? How did I misspeak and mistype? A is larger than B. Oopsie, I made A medium and B large. Let's make A large and B medium. Is everybody okay? All right. So one of the nice things about Tarski's world is that it allows you to see what you're trying to do in terms of these inferences. All right. So A is larger than B, B is larger than C. Can you, in Tarski's world, create blocks such that it's not true that A is larger than C? Right, and so Kyle, good for you. Every time you try to falsify number 3, you run into a contradiction, right? Trying to falsify number 3 is going to lead you to contradict either number 1 or number 2. Okay, you may not know it, but you understand the concept of validity, aka the concept of logical consequence, which is going to be the core of what we're working on Thursday, in addition to talking about our homework and submit and getting ready for our first exam. Okay, so validity is a core concept. I want us to start talking about it now so that we're prepping ourselves. Kyle, what are you thinking?
Oh no, I'm just
You're
good.
okay.
Yeah, I'm fine. Yeah, no, I was good.
All right. So, do you see the difference between what we just did and the earlier argument, where these two sentences, C is larger than F, A is larger than F, they don't force us into an inference. Whereas A is larger than B, B is larger than C forces us to an inference. You okay with that? Okay, so what do we want to know how to do? You're going to be able to jump into chapter 1. You're going to be able to start working with atomic sentences. Okay? Then make your way as much as you can into chapter 2 with a focus on your understanding of an argument in the sense of a collection of sentences, one of which is supported by the other or others. And then see if you can begin in the homework to start working on, see if you can begin to start, good Mia, see if you can start working on the concept of validity in the homework, Okay? And of course, if you have questions, problems, confusions, let me know. Thursday, we've got, we're going to basically pick up with chapter 2. We're going to focus on validity and AKA logical consequence. We're going to focus also on analytical consequence. We'll chat about soundness. We'll find that soundness is a tough concept for us to sustain in logic. More on that later. We'll talk about how we can demonstrate that an argument is not valid. That is, that an argument is invalid. Right? So, does anybody need anything in terms of satisfying questions about the programs? Homework? You're good so far.